Hello all to the lecture series of Digital Electronics KE 039/049. Myself Dr. Kishanu Kundu, Assistant Professor, Department of Electronics and Communication Engineering, GL Bajaj Institute of Technology and Management, Greater Noida. So, we are in lecture number 16, and in the previous lectures we have discussed about the different type of flip flops. There are 4 flip flops, namely SR flip flop, JK flip flop, D flip flop and T flip flop. Okay. So, now the question comes of flip flop conversion, means suppose you are having the SR flip flop and you want to work it as JK flip flop. So, the conversion, already you have studied about number system conversion from decimal to hexadecimal, decimal to binary, like that. Now, we are going to conversion of flip flops from JK to D, D to SR. So, this thing we are going to discuss in today's lecture. So, let us start the session. So, now first of all we will discuss the steps of flip flop conversion. Already in the previous slides we have discussed about the different type of tables. There are different tables like characteristic table and then excitation table, and those table will be useful for this flip flop conversion. If you having any doubt of characteristic table, excitation table, you can refer the previous slides. Okay. Then only you will be betterly understand today's topic. So, let us start the steps. So, whenever we are going for a conversion from one type of flip flop to different second type of flip flop, first of all we will check then what are the available and what is the required flip flop. What is available and what is required. Suppose I want to convert from JK to SR. So, in this case the available flip flop is JK and required flip flop is SR. Similarly, if we want to convert from D type flip flop to T type flip flop. So, now available flip flop is D and the required flip flop is T. So, first thing is to identify the available and required flip flop. So, once we identification is done, then go for the next step, that is design characteristic table for the required flip flop. So, now if the D flip flop to T flip flop conversion is there, so D is available and T is required. So, what we have to do? We have to draw the characteristic table of the required flip flop, means the T flip flop. Okay. Next, go for the third step, design excitation table of the available flip flop. So, if we are going to convert from D to T flip flop, so available is D and required is T. So, now we will make the excitation table flop D flip flop. So, clear? Our available flip flop is D, available is D and required is T flip flop. So, we will make characteristic table of T flip flop and excitation table of D flip flop. Clear? Okay. Now, the fourth point, write Boolean expression for all available flip flop. So, available flip flop is D flip flop. So, we will draw the final Boolean expression for that, and now finally draw the final circuit diagram. So, once the Boolean expression you have get, then it is very easy for you to draw the final circuit diagram. So, let us take an example and discuss. See, the question is conversion of JK flip flop to D flip flop. Conversion of JK flip flop to D flip flop. So, first step is identify available and required flip flop. So, here your available is JK, available flip flop is JK flip flop, and your required flip flop is D flip flop, required flip flop is D flip flop. Is it clear to you? The first step is done. Now, the next step is design characteristic table for required flip flop. So, here required flip flop is D flip flop. So, we have to design the characteristic table for required flip flop. In previous lecture we have discussed the characteristic of required D flip flop, and that we are going to write once again. Qn and D, two inputs. So, the combination is 0 0 0 1 1 0 and 1 1, and we know for D flip flop Qn 1 is equal to D. So, whatever the values will be of D, the same will be the value of Qn plus 1. So, we will just copy this whole thing here 0 1 0 1. Is it clear to you? So, our characteristic table is made. Clear up to this? We have identified the available and required flip flop, then we have drawn the characteristic table of required flip flop. Again I am telling, if you have any doubt about characteristic table, excitation table, final truth table, then just refer the slides for SR flip flop, JK flip flop and D flip flop. It is already discussed in those lectures. Okay. So, now next step is excitation table of available flip flop. You can already check here, design excitation table for available flip flop. So, here our available flip flop is JK flip flop, our available flip flop is JK flip flop. So, we will now draw the excitation table of JK flip flop. Now, we will design the excitation table of JK flip flop. So, here Qn plus 1. So, 0 0 0 1 1 0 and 1 1, and if you follow the lecture slide for JK flip flop, you can easily get it from there that the excitation of JK flip flop is written like that: 0 cross 1 cross 1 and cross 0. Already you have discussed this in detail in previous lecture. So, you can refer there. So, the excitation table is also made. Okay. So, now with the use of this characteristic table and excitation table, now we are going to design the final table. Okay. This is the final table. So, here you can check the fourth part is write the Boolean expression for the available flip flop. So, our available flip flop is JK flip flop, here available flip flop is JK flip flop and required flip flop is D flip flop. So, we are now merging both the excitation table and characteristic table and we are writing the final table. So, here again we will be writing like this. If it is not visible, I can like that, you can write like this: D Qn plus 1 and J and K. Okay, this. So, let us check Qn D. So, we are having 0 0 0 0 0 0 0 0 1 1 0 1 1. In the previous slide itself we are getting this. So, this already we have got. So, now we are putting these two things, you can easily for you see. Now, already we have written the excitation table here. So, using the excitation table we are making this one, this. So, check when these are the inputs, this is next state and these are the outputs. Okay. So, let us check the condition, let us check the condition when Q and N and Qn plus 1 is 0 0, the output is J and K is 0 cross. So, here you can see when Qn 0 and Qn plus 1 0, then the J and K value will be 0 and cross. So, we will write like this, K will be 0 and cross. Okay. Now, next check when Qn and Qn plus 1 is 0 1, then Jk will be 1 cross. So, let us check here Qn 0 and Qn plus 1 is 1. So, 0 1 cross will be having 1 and cross. Similarly, here Qn 1 and Qn plus 1 is 0. So, let us check Qn 1 and Qn plus is 0, sorry, this condition, sorry. Qn 1 and Qn plus 1 is 0. So, there we will be having cross 1. So, we will be writing like this, it will be cross 1, and the last condition Qn 1 and Qn plus 1 is 1. So, for this we will check here Qn 1 and Qn plus is 1. So, there we will be having the values for J and K is equal to cross and 0. So, let us write like this cross and 0. So, this the final table we have made using the excitation table and characteristic table, right. Actually, now what we are doing? We are writing the JK flip flop parameters in terms of D flip flop, because we have to make it will convert JK flip flop to D flip flop. So, this is clear to all of you. Okay. If it is not visible, I can write, we are having like this, JK will be like this, 0 cross 1 cross cross 1 and cross 0. Just I have written here because this is missing, I think. So, like that we have written. Okay. So, now what is the next state? The next is draw the final circuit diagram from the Boolean expression. So, now we have to write the Boolean expression. Okay. Fourth step is write the Boolean expression for the available flip flop. So, now let us check the Boolean expression. So, here there are two outputs I have written here. These are the two outputs J and K. So, one K map will be for J and one K map will be for K. One K map for J and one K map for K, and the inputs are Q1 and D. Let us, these things are very clear. The inputs are Q1 and D, and this is the next state Qn plus 1. Okay. So, when we are going to write the K map, we will be having one will be for J and one will be for K. Okay. And the inputs are Qn and D. Here also inputs are Qn and D. So, 0 1 0 1, okay, and this is 0 1 and 0 1. If you have any doubt regarding K map, you can refer the previous lectures. Okay. So, now for J we are having 0 1 cross cross, already in the previous slide you can check J is 0 1 cross cross. So, let us check like that 0 1 cross and cross. Okay. And for K, let us check what is there. For K it is cross cross 1 0, cross cross 1 0. So, we will be write like this, cross cross 1 and 0. Okay. Now, we will be do the grouping. So, here only one group is made because this is do not care condition. So, from this we will be write like this is nothing but J is equal to D. This is the equation for J. The output J will be having, J will be D. Okay. And for K we will be having this grouping. So, this is nothing but K is equal to D bar, because this is D bar, this is D, this is Qn bar and this is Qn. So, this is D. So, we will be having two equation, one is J is equal to D and K is equal to D bar. Okay. So, now the final step here it is draw the final circuit diagram. So, in the question you are having available flip flop is JK flip flop. So, now this flip flop will be JK flip flop, because we are having JK flip flop as available flip flop. So, this is JK flip flop. Now, we are getting J is equal to D and K is equal to D bar. So, now we are having one input as D and it is directly connected to J and K is connected to the implemented form, right, and already we have also will be having clock. So, this is the flip flop conversion. We are having the JK flip flop, but now we have converted into the D flip flop. So, as it is JK flip flop, but now it will be working as D flip flop. So, this is very important, the flip flop conversion from JK to D flip flop. Let us take another example. So, it will be easy for you to understand. Now, the conversion of SR flip flop to JK flip flop. So, already the steps are that first of all we have to identify the available flip flop and required flip flop. So, here available is SR, available flip flop is SR and required flip flop is JK. So, available flip flop is SR flip flop, available flip flop is SR flip flop and required flip flop is JK flip flop. Available flip flop is JK flip flop. Now, we have to make the characteristic table of SR flip flop. No, required is JK. So, the characteristic table will be for JK flip flop, right, and excitation table for available flip flop means for SR flip flop. Is it clear to all of you? Okay. So, now let us begin. We will draw the characteristic table and the excitation table as well. Okay. So, characteristic table for JK flip flop. So, here for characteristic table for JK flip flop, and next will be the excitation table for SR flip flop. If you have any doubt regarding the characteristic table, excitation table of these flip flops, you just refer the previous lectures, it will be easily understood by you. Okay. So, let us make the characteristic table. So, for JK flip flop we are having Qn, J and K and Qn plus 1. Okay. So, if we are having 3 conditions, so 3 input 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay. So, input side is made. So, we know that for JK flip flop, when the both the inputs are 0 0, the next state will be the same as of the previous state. So, here Qn is 0. So, we will be having Qn plus 1 is also 0. Okay. Same like that, when both our inputs are 0, the Qn plus 1 will be same as Qn. So, here Qn is 1. So, we will be having as 1. Let us check this one. Okay. Means when both the inputs are 0, next state will be the same as the previous inputs, next previous state. So, this is same as Qn. Okay, memory. So, here also the Qn plus 1 is same as Qn. So, here Qn is 1. So, now it is 1. Is it clear? When both are 0 and 1, so we will be having Qn plus 1 as 0. When 1 0 we will be having as 1. Now, when both the inputs are 1, then the next state will be the toggle of the complement form of Qn. So, this is nothing but Qn bar, and here Qn is 0, means it will be 1, the complemented form. Is it clear to all of you? Here same like that, this is 1 1, both are 1. So, it will be the complemented version Qn bar. So, here Qn is equal to 1, here Qn is equal to 1. So, now this will be 0, the complemented version, okay, and rest are 0 and 1. Already this characteristic table has been discussed in the previous lecture, you can refer there. Again I have told you the characteristic table. So, this is nothing but 0 0 1 1 0 1 0. Now, for excitation table of SR flip flop, so Q1 and Q plus 1, so will be 0 0 0 1 1 0 and 1 1. So, for this the excitation table of SR flip flop is nothing but 0 cross 1 0 0 1 and cross 0. 0 cross 1 0 0 1 and cross 0. This is the excitation table of SR flip flop. Now, what we have to do? The fourth step, this is write Boolean expression for the available flip flop. So, we have to make the Boolean expression, and for that we have to combine this excitation table and characteristic table. Okay. So, here it is excitation table and this is characteristic table. So, now we are having available flip flop is SR flip flop and required flip flop is JK. So, now we have to convert, we have to rearrange the inputs in terms of JK, right. So, let us do that. So, here we are having this characteristic table, and using this excitation table we will do more two input sides for J and for S and R, right. So, let us start here two more inputs will be writing like that S and R. So, let us complete this table. Let us check. We will just refer this table and we will complete here. Okay. So, how to do that? See, q n 0 and q n plus 1 is 0. Okay. Q n 0 and q plus 1 is 0. So, in this see, in both the cases q n are 0 and q plus 1 is 0, but j k is here 0 and cross, S and R are 0 and cross. So, we will be write as 0 and cross, 0 and cross, right. Next, for q n plus q n and q plus 1, 0 1. So, what are the conditions? These two, 0 and 1. So, for 0 and 1 we will be having S and R as 1 0. So, we will be writing as 1 0 and 1 0. Now, for q n and q n plus 1 0, see this one and this one, q n and q plus 1 is 1 0. So, in this case we will be having as 1 0 as 0 1. Okay. So, for this we will be having cross 0, 0 1 and 0 1 this. Okay. One second. These two cases will be having 0 1 and 0 1, clear, because q n and q n plus 1 is 1 and 0 and the last condition is 1 1. So, here see q n is 1, q n plus 1 is 1, here is q n 1 and q plus 1 is 1. So, in this case we will be having the S and R as cross 0. So, here cross 0 and cross 0, got it. So, we will be completed this table. So, now using this we will be having two outputs S and R. So, one K map for S and one K map for R. Let us begin that. Here one K map for S and one K map for R. Okay. And the input side what will be there? See, this is these three are input and this is next stage. So, q n j and k, q n, this is q n j and k, here also q n j and k. So, 4 combination 0 0 0 1 1 1 1 0 and 0 and 1, here also 0 0 0 1 1 1 and 1 0, this is 0 1. If you have any doubt of K map, please refer the previous slides of K map. Okay. So, now we will be putting that values of S and R into the K maps. So, like that will be coming as 0 0 1 1, then cross 0 0 cross. Okay. And for R it will be coming as cross cross 0 0 and 0 1 1 0. Just refer to the previous slides, from this only we have made that, from this table, from S and R. Okay. From this two have made that K maps. Okay. So, now grouping, this only one group is made here. So, what will be this value? This is nothing but S is equal to, see, it will be q n bar j, q n bar j. Okay. And here we will be having one group only this. For R we will be having R is equal to q n k, R equal to q n k. Okay. R will be q n k. Clear? For S we will be having one equation as q n bar j and for R will be having q n k. So, now the final state, the final circuit diagram, here available flip flop is SR flip flop. So, my available flip flop is SR. So, it will be S and R, this is Q and Q bar, SR flip flop. Okay. So, now S will be connected to the q n bar j. So, if we put as q n and q n bar. Okay. So, this is q n bar j, q n bar and j will be ANDed and we will be having the input as S, and next is R is equal to q n k. So, R will be Qn, this is Qn and this is K. So, this will be NANDed. So, it will be act as input R. Okay. So, these are very important, this is Qn and this is Qn bar. So, now this is the converted flip flop which will be acting as a JK flip flop. Okay. Our available flip flop was SR flip flop and now it will work as at JK flip flop, because the both inputs are J and K. Is it clear to you, all of you? Okay. So, in this lecture video we have discussed about the flip flop conversion. We have taken two examples. First of all, we have converted JK flip flop to D flip flop. For that we need the excitation table and characters table concept, which will be you will be getting from the previous slides, and then we have taken the example of SR flip flop to JK flip flop, and this is the final diagram. So, thank you.